Hello, 8th graders, and welcome to the last math chapter of your 8th grade career. Yeah, 10.4, surface area and volumes of similar solids. Now, just because it's the last math chapter doesn't mean we're going to stop. I might, bring in some Algebra 1 stuff. I might just do some review stuff. I might find some fun stuff for us to do next week. I haven't 100% decided yet, but this is the last chapter of our book. This is the last section of our book. And so we are going to finish up this book with this chapter, and then we will have a quiz, and then we will have a review, and then we will have your chapter test, and then you will have completed an entire year's worth of 8th grade math. So, little sad for me that we're not completing this together. I'm going to be honest. I'm having a little bit of a hard time thinking about the fact that we're finishing up our 8th grade book and we're not together in the classroom to, kind of cement this monumentous occasion. But we'll all survive. So, without further ado, let us get started. Chapter 10.4, surface area and volume of similar solids. Our learning target is to find the surface area and volume of similar solids. Success criteria, I can use corresponding dimensions to determine whether solids are similar. I can use corresponding dimensions to find missing measures in similar solids. And I can use linear measures to find surface area and volume of similar solids. So, similar means that they have the same relative shape, but they're not the same size. For instance, here's a right triangle, and here's a right triangle. This might be a 3, 4, 5 triangle, and this is a 9, okay, 12, 15 triangle. They are similar, which means they have the same ratio of sides. So for instance, this side right here and this side right here, this would be if I did big to little, this is a 9 to 3, which reduces down to a 3 to 1 ratio. Okay? And it's the same for all three sides, okay? If we look at this side right here, okay, we get 15 to 5, which reduces down to 3 to 1. If we look at the base, 12 to 4 reduces down to 3 to 1. And so how I can use this is, say I knew that these were similar, right? I know that these are similar, but they only give me 9 and 12, or 9 and they just give me the 9 even, okay? And they tell me that the two triangles are similar, and they tell me to find the missing sides. Well, because they're similar, I know that I can use this 9 to 3, which gives me that 3 to 1 ratio, and I can say, okay, if it's 3 to 1, for every 3 here, I have 1 here. That means I'm going to multiply each of these by 3 to find their missing dimensions. And that's how we use, I'm reviewing this because you should know this as 8th graders, but that's how we use similarity to find missing dimensions in similar objects, okay? So let's go ahead and start off with similar solids. Similar solids are solids that have the same shape and proportional corresponding dimensions. So there's that similarity that I was talking about in proportional corresponding dimensions. Okay? So it says which cylinder is similar to cylinder A? So this is our cylinder that we're going to be looking at here. This is the main one we're concerned about, and we want to figure out if cylinder B or C is proportional. Okay? So what we're going to do is we're going to look at the height of A, and compare it to the height of B. And then we're going to look also at the radius of A and the radius of B. Okay, and these, remember, with our triangle that I just showed you guys, every side had the same 3 to 1, okay, 3 over 1. So when we look at our height here, our height of A is 4, and our height of B is 3, okay? Now let's look at our radiuses. Our radius of A is 6, and our radius of B is 5, okay? Now, to get from, like, 6 to 4, that's like 2/3. To get from 5 to 3, it's not 2/3. These don't reduce down to the same lowest fraction, okay? So these are not proportional. Okay? That's what we'd say, not proportional, because they don't equal the same fraction, okay? Now let's look at A, compare A and C. So first we're going to look at the height of A over the height of B, and we're also going to look at the radius of A over, oh, I'm sorry. That's not A. This time we're doing C. The radius of C. Okay, so our height of A is 4 and our height of C is 5. Our radius of A is 6 and our radius of C is 7.5. Okay, so now here's what I have to do. I have 6 over 7.5. I have to figure out if that reduces down to the same 4/5. Okay? Like, screw it, how do I do that? Well, you know, really, what I do is I do 4 divided by 5, and that equals 0.8. And then I do 6 divided by 7.5, and that equals 0.8. And so they're proportional. This is equal to 4/5. Okay? Does that make sense? I could also do 7.5 divided by 5, which is 1.5, and do 6 divided by 1.5, and I get 4. So I did 7.5 divided by 5, which is 1.5. So that tells me I take this 5 and I multiply it by 1.5 and I get 7.5. If I take this 4 and I multiply it by 1.5, I get 6. And 6 over 7.5 is what we got here. Woohoo! So we are proportional. So that means that cylinder A is similar to cylinder C. That means that these two cylinders, okay, are similar to each other. And that means I can find all kinds of dimensions using those two. So go ahead and start doing the try it. So I've noticed that over the last week, my viewership of my YouTube videos has gone down. And so I have people asking me questions. Miss Curley, I don't know how to do this. Miss Curley, I don't get it. And I say, well, did you watch the video? And they're like, no, not really. I just watched the videos in the big ideas. So we're going to have a keyword in our videos from now on. And if I ask you to identify the keyword, and I'm just going to throw it in random places. It's not going to be in the beginning. It's not always going to be at the end. Sometimes it'll just be in the middle. So the key word for this video is pumpkin spice. Why? I don't know. I just felt like it. So if at some point you're like, Miss Curry, I don't understand how to do similar solids, and I say, okay, did you watch the video? And you say, yeah, I just watched it. And I say, okay, what's the keyword? You better be able to say pumpkin spice. Because if you can't say pumpkin spice, I'm going to know you didn't watch my video. All right. So let's look at the try it. It says cylinder D has a radius of 7.5. No. Here's my cylinder. It's not perfect. Mine never are. So it has a radius of 7.5 and a height of 4.5. It wants to know which example is similar to cylinder D. So if we put our height over our radius, we get 4.5 over 7.5. We have to figure out which one this reduces down to. So we know that A is 4 over 6, B is 3 over 5, and C is the same 4 over 6, okay? So let's just for a whim, look at B. So let's do 7.5 divided by 5. 7.5 divided by 5 is 1.5. Okay? Now let's do 4 divided by 1.5. 4 divided by 1.5 is 2.6 repeating. So it is not similar to B. It is not similar to B. Or is it? Did I do something wrong? Hold up. I think I did something wrong. Because I looked at my answer key and my answer key says try it is B. I thought it would be. So height 4.5, radius 7.5. Here's what I want to do. B, which was 3 over 5. Right? I'm going to do 4.5 divided by 3 is 1.5. What did I do? 4.5 divided by 3 equals 1.5. And then if I did 7.5 divided by 1.5, I get 5. And 4.5 divided by 1.5. Oh, I know what I did, guys. That's why when I entered it in my calculator the first time, I entered just 4 and not 4.5. Okay? So this does reduce down to 3/5. It is similar to B. It is similar to B. Okay? Duh. All right, example 2. In example 2, we have to find the missing measure in a solid, okay? So this one, they're going to tell me the cones are similar. I know they're similar. I know they're proportional, okay? Find the missing slant height, or L. So what I'm going to do is I'm going to compare the radius of X over the radius of Y, and it has to be equal to the slant height of X over the slant height of Y. Because they're proportional, they're going to be equal. Now, Michael, you used to love to do these. So think back. Michael, watch this. So let's look at our radiuses. My radius of X is 5. My radius of Y is 7. Okay. My slant height of X is 13. And I don't know my slant height of Y. They're set equal to each other, which means I can use cross products. Okay, so 5 times L is 5L, and 7 times 13 is 91. So now I have an equation, 5L equals 91. Divide both sides by 5, and I get that X, or L, sorry, in this case L, for the slant height, is equal to 18.2. Okay. Super, super simple, guys. This is just proportional relationships, using similarity, plugging it in. Okay. Use that. Use what you already know. So let's look at the try it. Okay. Oh, come back. It says the prisms at the right are similar, so we know they're similar. Find the missing width and length. Okay, so let's start by let's label these. Let's label this one X and this one Y, just for the fun of it. Okay, and we're gonna look at the height of X over the height of Y, and we're gonna say that's equal to the width of X over the width of Y. Okay, I'm just kind of going clockwise here. So the height of X is 8, the height of Y is 20. The width of X, I don't know. We're going to say that's W for width. And the width of oh crap, guys, I'm doing this backwards. It doesn't really matter. It doesn't really matter. Okay, this one's Y, this one's X. That's all I had mixed up, okay? So we've got our height of x is 8 right here. Our height of y is 20 right here. Our width of x, we don't know. And our width of y is 8, okay? Cross multiply, 8 times 8 is 64 equals 20w. Divide by 20. W equals, what is that? 3.4. 60 divided by 20 is 64 divided by 20. Go to bed, baby. 3.2. So our width is 3.2 inches. Okay? Now let's find our length. All I have to do is replace this part right here because we're going to use this same ratio right here, the same proportional relationship right there. So this time all I'm going to say is length, I don't know, of x, but length of y is 11. Okay? And then I'm going to do that same cross multiplication. 8 times 11 is 88. 20 times L is 20L. Divide by 20. Length equals 4. 88 divided by 20, 4.4 inches. So I found my width and my length using that proportional relationship. And those answers are right. I did check them. All right, moving on. We have another key idea. Linear measures. Looking at surface areas of similar solids. So when the solids are similar, the value of the ratio of their surface area is equal to the square of the value of the ratio of their corresponding linear measures. Oh my goodness, could they make this any more complicated? Okay, basically, the surface areas, the ratio of those is equal to the measurements squared, okay? So let's just get right into it. Let's look at pyramid A. Let's look at example 3. It says the pyramids are similar. We want to know what the surface area of pyramid A is, okay? We know that they're similar. So we're going to look at surface area of A over surface area of B is going to be similar to what do we have here? What measurement did they give me of this prism, of this pyramid? They gave me the height, right? I have the height of both. So I'm going to say the height of A over the height of B. And this is where I said it was squared, okay? So we're going to have to square that. So surface area. So let's plug in some missing pieces. Surface area of A, I don't know. That's what I've got to find, okay? Surface area of B, they tell me is 600, okay? The height of A is 6 and the height of B is 10. Square it, okay? So A over 600 is equal to 36 over 100. And again, we're just going to cross multiply, okay? So I'm going to use my calculator. And I'm going to say 36 times 600 is 21,600. And that's equal to 100A. Divide by 100. And we get that A is equal to 216. Now remember, this is surface area, okay? So it is going to be squared. We're dealing with feet here, so it's feet squared. Okay? Again, the only thing that was different here is that when we're dealing with surface area, we have to square the length and width and height and all that good stuff, okay? You square the side lengths in that formula. All right. Do the try it. Pause it. Do the try it. I'm going to start working on the try it now. Whoop. All right. It says the solids are similar. Find the surface area of the red solid. Round your answer to the nearest tenth. Okay? So we have red over blue. And this is surface area. is going to be equal to height of red. Well, that's not really height. What do they give us? What is that? What would you call that? Would you call that the width? Width of red over width of blue. Okay, so we don't know. So let's call this x over, and they give us the surface area of the blue at 608. And then they give me 5, and they give me 8. Okay, so 608 times 5 is going to be 3,040 over 8x. Divide by 8. And I get 300 and... Well, I got 380. But my answer key says that's wrong. I don't know how that's wrong. 608 times 5 is 3040. Divided by 8, I got 380 again. Oh, guys, come on. I'm a dummy. I'm a dummy. I didn't square it. I'm trying to be all fast and cool and didn't square it. Missed a key step there. X over 608 is equal to 25 over 64. That's going to make a difference. 608 times 25 is 15,200 equal to 64x. Divide by 64. And you get that x, or our missing surface area, is equal to 237.5 meters squared. Okay, so that was try it 3. Don't be like me and forget to square it. Good thing I have an answer key sitting right here in front of me. Okay, so on this one, they give us the diameter. Let's work with it and see. So we have red over blue equal to red over blue. We have red we don't know, so that's R. Blue is 110. And then we have 5 over 4, and we need to square that. So R over 110 is equal to 25 over 16. 16R is equal to 200. Oh, I almost just did 250. I almost just did that times 100 instead of... Okay. Instead of 110. Divide it by 16. And we're rounding, so that's R is equal to 171.875. It says to round it to the nearest tenth. So that's going to be 171.9 centimeters squared. There you go. Remember to square it. Okay, and then it's just a matter of doing that cross multiplication, right? Cross multiplication. And that's where we get the 16R and the 2,750. And then we divide by 16. Divide by 16. And then we're rounding. And because we're rounding to the tens place, we look at the tens. We look at the hundreds after it. The 100 was above 5, so we round up. Okay? All right. Last key idea. Last example. When we're looking at volume of similar solids, so now we're looking at the volume of it, okay? We did surface area, now we're looking at volume. Remember that volume is always cubic, so we're going to use the same formula, we're just going to cube it this time. So when two solids are similar, the value of the ratio of their volumes is equal to the cube of the value of the ratio of their corresponding linear measures. So, same basic thing. So when we're looking at example... Oh, I'm sorry, we have example 5. Dang it. Okay, so when we're looking here at example 4, it says the cones are similar. What is the volume of cone A? Round your answer to the nearest tenth. So volume of A over volume of B is equal to height of A over height of B cubed. Cubed, okay? So the volume of A we don't know. The volume of B is 288. The height of A is 5. The height of B is 12. going to cube it. Okay? So A over 288 is equal to 125 over 1,728. 1,728 times A is equal to 125 times 288, which is 360,000. Yeah. Divide it by 1,728. You get 20.8. And then we are dealing with volume, so centimeters cubed. Okay, our volume equals 20.8 centimeters cubed. I rounded, so did they. Okay? Same thing, except for because you're dealing with volume, you cube it instead of square the side lengths, the ratio of the side lengths. Okay, let's look at the triad. The pyramids at the left are similar. Find the volume of the red pyramid. Round your answer to the nearest tenth. So V of red over V of blue equal to base. Nope, hold on. That's the area of the base. Base of red over base of blue cubed. Okay. Volume, we don't know for the red. We know it for the blue. It's 9. Base for the red is 4. Base for the red is 3. For the blue is 3. Cube it. 4 cubed is 64. 3 cubed is 27. 27V equals 9 times 64, which is 576. Divide each side by 27. You get 21.3. Hold on, I gotta turn my page over here to make sure I'm correct. 21.3 inches cubed for the volume of the triad in 4. And it's actually 21.3 repeating, but we rounded. Okay? All right, example 5 is our modeling real life. This is our last example. It says the dimensions of the touch tank and aquarium are doubled. How many pounds of water are contained in the new tank? And it says 1 cubic foot of water weighs about 62. So we have an original volume and a new volume, okay? We have our original tank, okay? So let's look. We've got the OG volume over the new volume. And we know that they're proportional. We've got the OG dimensions over the new dimensions. And we're dealing with volume, so we're going to cube it. Okay? The OG volume, we know. The original volume, right here, 2,000. We don't know the new volume. Okay? So V. And we know that the relationship is 1 to 2. It's doubling. Okay? So for every 1 in the original, we have 2 in the new. Does that make sense? Okay? So that gives us 2,000 over V is equal to 1. 2 times 2 times 2 is 8, not 6. 8. Okay? 8 times 2 is 16. So 16,000 equals the volume. Okay? That's our volume. They're not asking us what the volume is. They're asking us how many pounds of water in there. And they tell us that 1 cubic foot of water weighs about 62.5 pounds. We have 16,000 cubic feet. Okay? We have 16,000. So basically what we're going to do is we're going to take this 16,000. So we're going to say 16,000 feet. Let me see, I need more room. I thought I got the eraser. I did not get the eraser. Eraser. Okay. Rawr. Rawr. Up. Okay, right there. So we have 16,000 feet cubed of water. And we're going to multiply that by 62.5 pounds per 1 foot. Okay? B's cross out. So basically, we're doing 16,000 times 62.5, which gives us 1 million. Okay? So the new tank holds 1 million gallons, or no, I'm sorry, not gallons, pounds of water. Agua fria. Okay? All right, I hope all of that made sense. It's basically cross multiplication. It's just plugging into formulas. Remember, if you're doing surface area, you square it. If you're doing volume, you cube it. If you have any questions, you know where to find me. And the code word for this lesson was pumpkin spice.